Okay, guys, so good morning. So, for today, we are going to learn about water and pH. So, for this lesson, we are just going to understand the characteristics of your water and understanding why water is the most important chemical in the world, I think, in the universe, for humans and for other organisms. And this is the core of our biochemical processes in the body. So, when you look at your water, okay, so this is the importance of it. Of course, almost all life have water. So almost everything has water, I guess. So 70% of our body mass is water. So the 30% there would be proteins and integrated proteins and lipids. So as you can read there, two-thirds of your total body water is intracellular. It means that the water are inside your cell, and the one-third of it would be the extracellular or the extracellular fluid. When we say ECF, they are the fluids that we can find in our bloodstream, in our mouth, the saliva. So they're all outside the cell. Okay. So in here, the tackling of your water in pH, we would also understand later the pH and the buffer system. So as of now, you have here the bicarbonate system, into which I will discuss it, and the changes of pH, the danger that it could impose to our body or could pose to our body. So let's proceed. So actually, here are the properties of your water. So you just have to remember that your water is made up of course, you know that already, two hydrogen atoms and an oxygen. So these two hydrogen atoms and your oxygen combine together, and when you combine these two, you will actually form a species that would be charged. It means that it is ionized, or the other end would be positive and the other end would be negative. So hydrogen and oxygen do not have a charge beforehand, but reacting together, they would form charges. So in here, in your PowerPoint, it says here that your water contains polar covalent bonds because oxygen and hydrogen do not share electrons equally. So if you recall your chemistry, we actually have different kind of bonds. So we have what we call your intramolecular bonds, that's number one, and the other would be your intermolecular bonds. So let me you can just spell it. So intramolecular bonds and your intermolecular bonds. When we talk about intramolecular bonds, they are actually bonds found inside the molecule or inside a compound. So let's say for example sodium chloride, so they are both a compound, so in between them there's a bond. Okay, so that's inside the compound, so that's we are going to call it so intramolecular bond. But when we talk about intermolecular, so we will learn that later. I think I have illustrations here. When we talk about intermolecular bond, it is actually the bond existing. For example, hindi lang man isa sodium hindi lang man isa ka sodium chloride nga compound ang present sa isa ka solution. So maybe you have 3, 4, or 5 more compound species of your NaCl. So when you add your NaCl together in your water, the NaCl will dissociate and it will bond with the water. So the bonds of that sodium and your chloride with the water, the hydrogen and oxygen, so that would be called now your intermolecular. So magsiling ka inter, between, okay? Between two molecules. When we talk about intra, inside the molecule or inside the compound, okay? So here, you have to remember that your hydrogen in your H2O is a positive charge, and when we talk about the oxygen, it is electronegative and it is more negative in the structure. So when you talk about here, it forms a dipole. When we talk about dipole, di here means two. So it has two poles, thus calling water polar. Magsiling ka gani, polar, it has poles. Meron siya punta kag punta. So let's see an image of water. Okay, here. So as you can see, you have two poles. You have a pole that is positive and you have a pole that is slightly negative. So magsiling kaya gani non-polar molecule, it is usually symmetrical. Magsiling ka symmetrical, think I have an example here. So, magsiling ka symmetrical, are, there are four electrons or atoms here shared equally. So, when you put an axis in here, sa tunga sa imo methane, look at methane. So, if you put an axis in the middle line, what happens? Your structure will just be divided into two equal parts. So, that's what we call symmetrical. When we talk about polar, they won't uh, present itself into a symmetrical way. So in here, sa water mo, as you can see, okay, it has two poles. And here, your ammonia, when you put an axis in between, okay, it will become, okay, non asymmetric. So amo man sa imo water. So, but your water actually cannot really be what we call fully called as polar molecule. It can also act non-polar depending on the compounds that it reacts with. So in here, when you look at it, water can be asymmetrical, but water can be symmetrical when you look at it. But the thing is, it is actually bent. It has an angle. That's why we can't just see this into a linear image. Okay, so when you look at water, so it has actually an angle. So it's not just like that. Nga isa lang ka image nga nagatubang sa aton. So water is polar mostly, but it can act non-polar depending on the compound that it would react. So we can't base it according to the symmetricality, but usually all your polar compounds, like your ammonia, can be divided and then they will become asymmetrical. Okay? So, or as you can see, there's a negative pole, there is a positive pole. Here in your non-polar, there are no charges at all. There is no positive, there is no negative. Okay, so here also in your water, there is negative and there is positive. Okay, so the characteristic of your water, or the other characteristic of your water, is actually its potential for hydrogen bonding. So when we talk about hydrogen bonding, of course, so there must be the presence of your hydrogen, and it only exists usually in your water. And a certain hydrogen should be partially charged in here in order for it to bond to a highly negative or highly electronegative chemical. So as you can see here, we have a covalent bond and we have a hydrogen bond. So, miss, nga aparehas naman sila, oxygen ni siya, hydrogen ni siya. Hydrogen ni siya, oxygen. Why is it that in this molecule, first molecule of water, the second molecule of water, why is it that in this molecule, oxygen and hydrogen has covalent bonding? So actually, your covalent bond would be under your intramolecular uh, kind of bond. When we talk about intra, amo tong hamaltagina, inside your molecule, there's a bond existing. So when we talk about covalent bond, this is actually the sharing of your electrons or the transferring of your electrons, but not really fully. So they are just sharing a certain electron, and within that sharing, it is not stable. So it happens usually with a metal and non-metal, but not all the time. Because as you can see, hydrogen and oxygen are not metals. So in your periodic table. So when you look at it, hydrogen and oxygen are both non-metals, but they actually have difference when it comes to the presence of valence electron. Magsiling ka valence electron, chemistry review. These are your electrons found in the outer shelves of your atom. So in your hydrogen here, it has only one electron, valence electron. In your oxygen, you have actually 6. So when you look at it, the oxygen actually pulls that one electron present in your hydrogen. So it's not the complete transfer because kung kwaon yung tanan ng nga electron kay hydrogen, ano na lang ang matabo. So there will be no existence for your hydrogen. So when we talk about covalent bond, it's all about sharing a certain electron, or it's not about transfer, but it's more of you are dependent on the vibration or depending on the charge of that certain molecule. So now, When you look at hydrogen going to another oxygen from the first molecule of H2O here going to the second molecule of your H2O, we have now your hydrogen bond. So when we talk about hydrogen bond, first your hydrogen must be positively charged or partially positive charge. Nga ang nag-positive charge na si hydrogen ta. It's because it shared its electron to your oxygen. So, di ba nung hamba ko, isa lang ang iya valence electron. Ang nag-iisa ito, gin-share ya pa kay oxygen. So now, what happens to hydrogen? It becomes more positive. Your oxygen here becomes more negative because it gains electrons. Remember that your electrons are always negative in charge and your uh, oxygen therefore is a strong electronegative compound. It means that it will attract more electrons to it. Okay? So in here, with the definition of your hydrogen bonding, it means that hydrogen should be partially charged or positively charged in order to it for it to form a bond with a electronegative element. So usually we have three mostly electronegative element. We have your FON, F-O-N. So write it down. We have your fluorine, oxygen, and nitrogen. So it just so happens that sa water, gini siya permiga katabo ang hydrogen bonding. So you have to really understand this one. The hydrogen bond now falls under your intermolecular bonding. Okay, so let me review. We have two general types of bond, the intra and your inter. Intra within the molecule, inter in between the molecules. So you form equivalent bond between hydrogen and oxygen in order to form one molecule of water. And what happens is that the oxygen is actually getting the valence electron present in your hydrogen, thus making it more negative and making your hydrogen more positive. And your hydrogen bonding is actually under your intermolecular forces, into which a certain molecule of water interacts to another molecule of water via this one. And in order for this to happen, you have first to make sure that your hydrogen is partially positive in order for it to bind to another electronegative atom. Okay? So gets lang? Goods. So this is the specific definition of a hydrogen bond. Matawambal ko. So take note of your three highly electronegative atom. The FON, fluorine, oxygen, and nitrogen. Okay? And let's proceed. The other characteristic of your water is actually it is kabalo na kamang kamuto kagina liwat, it is polar. So since it is polar, it dissolves mostly all polar compounds. So like dissolves like. Okay? Uso na siya sa pharmacy nga line. Like dissolves like. And when you dissolve a polar compound like your sodium chloride here, with that of your water, it dissolves. So sa inyo naman lang sa inyo kusina, magluto ka mo ang asin permigiga katunaw sa tubig. So when we talk again polar compounds, they are your charged compounds. They have two poles, which is the positive and the negative. And usually when you cut them in half, they are asymmetrical. So the other one is slightly bigger than the other pole. Okay? So now, when you look at the diagram, so your sodium chloride, imagine nun mo ang asin mo gimutang mo sa tubig. So usually, what happens to the sodium chloride is that it dissociates or it ionizes. Magsiling ka gani ionizes, it gains a charge because it dissociates in the water. So ang sodium ko kag ang chloride ko ma-separate. So now, this sodium and chloride has different charges. Si sodium ko positive, si chloride ko negative. So now, what happens? I've told you that water has two poles, the positive one and the negative one. So since your sodium is positive, your water will put its negative part, which is your oxygen, and it encloses your sodium so that it will be enclosed in a solvation shell, and then it will readily dissolve it in the solution. So same with your chlorine or your chloride. Your chloride is actually negative. So if it is in negative state, your water now will adjust. So it will slightly shift to its hydrogen part, which is the positive part, and it will again form solvation shelves, and then it will readily make your chloride dissolve in your solution. Okay, so water dissolves polar compounds, but unfortunately, your water cannot solubilize your nonpolar compounds. So example of your nonpolar compounds would always be oil, okay, or lipids, or some of your proteins that are actually nonpolar, but some of them are also polar. So it depends on the structure. So nonpolar are insoluble in water like your oil, but there's always an exception. So the exception for this would be soaps. Okay? Your soap could act as a micelle. Ariho, kita nyo yung micelle sa sulod ni. When we talk about a micelle, it is actually a species having a hydrophilic and hydrophobic area. So magsiling ka hydrophilic, philia, you are loving the water. When we say phobic, phobia, you are hating the water. So usually this is what a cell membrane looks like. So actually ang cell membrane ta mo man itsura. So your micelles are actually present in your soap and detergents. That's why they are soluble in water, but actually they are made up of fatty acids or fats. So it undergone esterification in order for it to become soap. So in order for you to dissolve something into water, maskin lipid ka pa, you have to be amphipathic. It means that you have two poles. And since water is also amphipathic, it means that it has two sides and it can act as polar or non-polar. So it can dissolve mostly anything. Okay? Nga may dual characteristics nga compounds. Okay? So next, let's move on. As you can see here, si ato ni nga hydrophilic, okay, the water loving side of your micelle. Okay, so in here the hydrogen faces your hydrophilic because of course this part is quite negatively charged. Okay, so amo lang man na siyang theory behind their solvation kung paano gakatunaw ang isa ka bagay. So ma-apply nyo ni gurong micellar nga mga term sa mga girls da para may magbakal sa Watsons, you find for your micellar waters. It is actually made up of kind of detergent-like nga formula. Okay, that's why ang mga oil-based nga mga makeup, it can be get rid of by your micellar water. And next, the other characteristic of your water, since it is polar and it has hydrogen bonding, is that your water has the capacity to auto-ionize. Again, your water has the capacity to auto-ionize. Magsilin ka auto-ionize, it has what we call your self-ionization process. So when you put water molecule to another water molecule, it would react simultaneously into making hydronium ions and hydroxyl ions. Again, when we talk about ionization of your water, this is another characteristic. So when you react or when you let your one molecule of water react to another molecules of water, it would simultaneously produce your hydroxyl ions and your hydronium ions. And as you can see here, your hydronium ions here are your acidic part and your hydroxyl ions are your basic parts. So this will now be the basis of our water dissociation constant that will be essential for our pH calculation later. Okay? So, ara naman siyang definition sa dalom, so you can read that one. And by the way, since H3O is kind of confusing when you look at chemical formulas, usually your scientist or your chemist just makes it shorter and just write it as H+. Okay? H+. So now, here goes the confusing part. So when we talk about ionization of water, so here, a molecule of water reacts with a molecule of water, produces now your H3O plus your hydroxide ion. This is your hydronium ion. But ang mga scientists gani hamal ko is tamaran. So you usually represent your hydronium ion into hydrogen lang nga free state, H+, so that it would be easy for us to write. So here, it's the same reaction, it's just it is in shortcut ang ari sa dalom. So here, the thing that we are calculating in this whole PowerPoint is just actually the water constant. So this is the basis of our pH later. So magkuha ta sang ariho equilibrium constant. Your equilibrium constant usually is based on your Le Chatelier's principle. So I guess in your chemistry, usually the reactant and its product are always in equilibrium. So your Le Chatelier's principle, just search for it since under siya sa chemistry mo. But ang aton that theory is to attain equilibrium. So kung may reactants ko, these reactants will be producing products. And these products will always be equal to the reactants nga nag-react. So it's quite basic. Nga syempre, nagpasulod ko hydrogen, nagpasulod ko oxygen, syempre, makaproduce ko water. Or it's either I put hydrogen and then I put water and then I will put it to another water molecule. What happens? It will dissociate into different ions. So these chemical processes, the energy that we are inputting and outputting will always be equal. So when you are solving for equilibrium constants, usually ang aton nga ginahimo is to multiply the products here. Hydrogen multiplied to your hydroxyl concentration. Generic formula ni siya, guys. Generic formula. This one. Okay? So, hydrogen multiplied to your hydroxyl ion over the H2O, which is your reactant. So, si water ta ang naga-self-auto-ionize. Okay? Siya ang auto-ionize. So, therefore, your water is your reactant. So always gina siya, guys, maskin any kind of chemical formula, in order for you to calculate the equilibrium constant of that, you will just be using the equation, which is the product of your products over the reactant. Okay? So it just so happens that in your water, this is how it looks like. So in here, we were given the equilibrium constant of your water. So wala ta na siya gin-calculate actually manually. But you just have to know that your equilibrium constant of your water would be at 1.8 times 10 to the 16th. So, can you see the H2O is equal to 55.5 molar? So, actually, that's the concentration of your water out of 1,000 ml. Okay? So, that's the concentration of your water out of a 1,000 ml quantity. So, with all of these numbers, okay, so this is how we all derive the 1 times 10 to the negative 7. So your hydroxyl and your hydronium ion has the value of 1.0 times 10 to the negative 7. But your water itself has a water dissociation constant, which is at 1 times 10 to the negative 14. Miss, ano naman ginapangwakal mo man nga dako damo na. But actually, ari lang i-highlight nyo, 1 times 10 to the negative 14 and your 1.0 times 10 to the negative 7, these are actually the values of your pH scale. So basically, in here, the Kw here stands for your water dissociation constant, and your 1.0 times 10 to the negative 7, it stands for the concentration of your hydronium ion and your hydroxyl ion in a 1,000 ml solution. So, kung amo ning aton ginasturyahan, ti ano na ang significance, miss? You are just going to multiply these numbers to a negative log. Why? In order for it to be expressed as your pH scale. So, ikaw ba naman, mangkoton ka, what is the water dissociation constant? Ma-answer ka pa 1.0 times 10 to the negative 14. So usually, this 1.0 times 10 to the negative 14, this is your 14 when you put a negative log to it. So here, let's move on. So for the pH, in here, we have what we call the neutral, which is your 7. So we have here your pH below 7, that is acidic, and your pH is more than 7. But the definition of your pH is a measure of the hydronium ion content of a solution. So as you derive in here, from the water dissociation constant na amount, you concluded that your hydronium and hydroxyl ion each have the 1.0 times 10 to the negative 7 molar concentration. So this now represents your pH. So when we talk about pH, this is the negative log of your hydronium. So the hydronium concentration, or the constant concentration of the H here for your pH would be your 1.0 times 10 to the negative 7. But since it's kind of hard to write it in a long way, we have to put negative log. The letter P here stands for negative log. And then you put the 1.0 times 10 to the negative 7, it will become 7. Okay? Actually, your pH is just easy. So let's take an example. Calculating it would be easy peasy because it's just mere substitution. But you have to just understand that your pH is the measure of how acidic a certain solution because of the presence of your H, letter H, the hydronium. So kung mas damo ka letter H, it means that you are acidic. If you have high concentration or high value of your hydronium, you are increased. Okay? But if you put it into a negative kind of way, of course, it will become opposite, or it will be an inverse relationship now. So, kita nyo to? Si H ta, 1 times 10 to the negative 7. So, if it becomes 1.0 times 10 to the negative 5, negative 3, it becomes more acidic. But since this is log, okay, we named it into negative log, or we converted it into negative log. What happens is that the higher the pH, the more that it becomes less acidic, the more that it will become basic. So, amula na kung H lang siya nga plain, kag taas akong concentration, it is acidic. But, if my pH now has become, diba, if ang H ko nga concentration ginhimo ko negative log, what happens? It's that it will become less acidic. Okay? So now, we have here your pOH formula also. So it's just the same. If you want to get the pOH, you just input negative log, OH dayon na concentration. But hindi nagtatapos da. You should always look out. What if OH OH din kinahanglan sa among formula? What if you were given the hydronium concentration? What you will do is just get the pH first and then substitute this into this formula and then derive for the pH. So I will insert the examples on how to calculate this one. Okay, for you to derive the pH of a solution by having the concentration as a given, or the hydronium concentration as a given, so you just have to input it in your general formula. So the given is actually 1 times 10 to the negative 5 molar. And then the formula for your pH to be derived would be negative log the concentration of your hydronium or hydrogen ion. So therefore, your pH is just negative log 1 times 10 to the negative 5. And when you input that in your calculator, you will derive now that your pH is 5. Okay? Therefore, this formulation is acidic. For the second problem, we are given OH is the given. The OH concentration, specifically the 1 times 10 to the negative 8 molar. So what is being asked in our problem is actually the pH. So you can just readily use the formula pOH is equal to negative log OH, but always mind that you will end up with pOH, not the pH. So what we will do is just substitute first to the pOH is equal to negative log times 1 times 10 to the negative 8. The answer now would be 8. Okay, so pOH would be actually equated to 8. But we're not finished with that because we are still going to derive the pH. So you have to remember that pKw is equal to pH plus pOH. So we already have the constant for the pKw, which is at 14. And your pH now is the one being asked. And your pOH was the value that we derived earlier, which is 8. So in order for you to transpose or to leave this pH in the side, you're going to just move your 8 in the side. So it will become 14 minus 8 is equal to pH. That would be basic algebra. So 14 minus 8 would be 6. So therefore, this solution is kinda acidic. So guys, no need to proceed to any kind of calculation. If pH man lang napangita sa inyo, kag may hydronium concentration na makamo, then that's it. But take note that if you were given the hydroxyl concentration and then you were being asked of your pH, so you still have to go through this formula. Okay, so that's it.